We talked about cubic equations. Okay, y is equal to x cubed. Now, as far as higher equations, we have cubic equations, we have quartic equations, which are fourth degree equations. We have fifth degree equations, so on and so forth. Now, we talked about how to solve a quadratic equation and all those methods. In order to solve higher order equations, those are equations in which the exponent is larger than 2. So in order to solve equations such as these, we use a combination of methods, the quadratic and the linear method. Okay. So in this chapter, or in this module, we're going to solve third, fourth, fifth, sixth, and seventh degree equations. Now, before we actually begin, I'm going to go back to the main screen for just a second, or to the shared screen, I should say. All right, and I'm going to just pull up Google for just a second. I want to type in something called the Nth Root Theorem. And I thought there was a better definition. Okay, we'll just take this one. Okay, so I'll go back to, I don't actually see what I'm looking for. All right, this is the Nth Root Theorem. And this is what's going to drive the number of solutions that your equations may have. And here's what it states. It states that the number of zeros, and we talked about what zeros are. Zeros are the solutions, the roots, the answers, the x-intercepts, right? When we talked about zeros, so the number of zeros or the number of x-intercepts you can have of a polynomial may have up to n roots n is the degree of your polynomial. Okay. All right, so the Nth Root Theorem states that the number of zeros of a polynomial may have up to n roots. So what do I mean when I say n roots? Where n is a degree of your polynomial. Right. I'm going to go back here for just a second. So what that means is for your linear equation, it has a degree of 1 because the largest power is 1. That means you can have up to one solution. Right? You may have no solutions. You can have one, but you can't have more than one solution for a linear equation. For a quadratic equation, it has a power of 2, right? Which means that a quadratic equation can have up to 2 roots, which means it can touch the x-axis up to twice, but no more than twice, right? You may have 0 roots, right? It may touch the x-axis once, right? And kind of bounce off. You may have no roots, right? And we talked about the imaginary solutions. And it also may have 2 roots. For your cubic equation, it's a degree 3. That means it can have up to 3 solutions, right? It can hit the x-axis 3 times. Quartic equations, those fourth degree equations, they can have up to 4 solutions, but not exceeding 4. Okay, so when we're solving let's say a cubic equation, you should expect to have 3 solutions, basically. If you're solving a quadratic equation, and we're going to get more into these later, y is equal x to the 4th degree, you can have up to 4 zeros or intercepts. All right. All right, so with that being said, we are going to review long division. And I'm actually going to use OneNote, so give me a second to reconfigure the setup. Okay, I'm going to explain long division, and then we're going to talk about synthetic division. And both methods are used to divide polynomials. Right? All of the methods are used to divide polynomials. Synthetic division is just a quicker method that's used to divide polynomials. Okay, so first we're going to take a look at long division. Because in some of these problems, you will have to use long division. All right, so in this first example, we are going to divide x cubed plus 2x squared minus 17x minus 10. We're going to divide that by x plus 5. Okay. So now, since Math 102 Intermediate Algebra was a prerequisite for the course, you should have been exposed to long division. So I'm going to give you a minute or so to work out the problem, okay, and then we'll come back and we'll take a look at the solution. All right, so let's take a look at the solution. Now, as far as our setup, what we're actually looking at here is x cubed plus 2x squared minus 17x minus 10. This is our dividend. And we have x plus 5 as the divisor. So when we set up our long division, we're going to put our divisor, which is x plus 5, on the outside, and we're going to put our dividend on the inside. Now we want to make sure that our divisor and our dividend are in descending order. So what do I mean when I say descending order? Well, if we look at the x plus 5 factor, notice that x has a degree of 1 and 5, which is a constant, has a degree of 0. If I look at my dividend, right, I have my first term is x cubed, so that has a degree of 3. We have 2x squared, that has a degree of 2. We have negative 17x, which has a degree of 1, and negative 10, which is a constant, it has a degree of 0. So notice I have descending order, 3, 2, 1, 0. If you're ever missing a term, you have to put in what's called a filler 0. All right, so everything is in descending order, so I'm going to write out my dividend. Okay, and now I'm going to proceed to divide. Okay, so I'm going to concentrate on my x plus 5, right, which is 2 terms. So I want to concentrate on the first 2 terms of my dividend, right? And more importantly, I'm going to concentrate on my x terms, these first 2 terms, x and x plus 3. Right? So I'm going to kind of go over here to the side. X, and I'm only concentrating on x here, times what would give us x cubed, right? And you'll see why I'm trying to figure this out in just a second. Well, x to the first times x to the second, that gives us x cubed. So that means that if I multiply x times x cubed, the product, if I multiply x times x squared, that product is equal to x cubed. So I'm going to take x squared, and I'm going to write that above that second term. Now, this is the reason why I don't write x squared above the x cubed term. It's because when I distribute, right, it's going to give me 2 terms. So when I multiply x squared times x, I have x cubed. And when I multiply x squared times 5, I have plus 5x squared. Right, so notice how the first terms will match up, right? And whatever happens with the second term, we'll take care of that on the next iteration. Now, you also have to keep in mind when you divide, right, using real numbers, the process is the same when you're using algebraic polynomials, right? For example,
Excuse me, we can't see your screen.
You can't see my screen?
No, it just went off.
I think I hit something. Give me a second. Okay, are you seeing it now?
Yes, we can see it now.
Okay, thank you for letting me know that. Okay, so where did I cut off exactly? I'll just kind of go back through it. So we multiplied x squared times x plus 5, right? So on the side over here, I kind of figured out what I had to multiply x by in order to get x cubed, right? And I figured that out as x squared. So then I taken x squared and I wrote it above the 2x squared term in the dividend. Right? The reason why I did not write it above the x cubed term is because when you actually take that x squared and multiply it by your divisor, it's going to give you two terms, right? So I multiplied x squared times x, so that's where the x cubed comes in. And I multiplied x squared times 5x, so that's where the 5x squared comes in. And I believe I hit this little thing, so I'm going to hide it up here. All right, so now the same process you use for real numbers is the same process you use for these algebraic equations. Okay, for example, I'm just going to go over here for a second and let's say we divide 3 by, I don't know, 54 or something like that. All right, so 3 can go on to 5 once without going over. 3 times 1 is 3, and then you subtract. So we're going to do the same thing here, but instead of subtracting, I'm going to do what's called changing the sign, right? So what I'm actually going to do here is I'm going to multiply everything in this row by a negative. Right, so here's what happens. This x squared becomes negative x squared. This 5x becomes negative 5x. The reason you must change the signs here is because you do it with real numbers. All right, so notice that over here, you would subtract, and then 5 minus 3 is 2. You bring down your 4. 3 times 8, okay, 24. Then you subtract, right? That subtraction is very important. All right. So now we're going to simplify. So once you change the signs, notice that these first terms will cancel, which is what you want to happen, right? So the first terms cancel. 2x squared minus 5x squared is negative 3x squared. And because we have two terms in our divisor, we must maintain two terms. So I'm going to bring down the minus 17x. So now I'm going to concentrate on this negative 3x term and this x term of my divisor. And this is what I'm going to figure out. X times what quantity is going to give me negative 3x squared. Right? Because what we want to happen is we want to make that first term exactly the same. Right, and then once we change the sign, that term will cancel, right, and then we'll just continue on to handle the other term, okay, in the division. All right, but x times negative 3x is going to give us negative 3x squared. Right, x times negative 3 gives us negative 3x squared. So I'm going to multiply by negative 3x. Right, so now I'm going to distribute 3x. Well, negative 3x. So negative 3x times x is negative 3x squared. Negative 3x times 5 is negative 15x. Right. So remember here, we must change the sign. right? So once we distribute that negative, okay, 3x becomes positive, right? Negative 15x now becomes positive. The 3x squared terms will cancel. Negative 17x plus 15x is negative 2x. Right. So now I'm going to concentrate on this negative 2x term and x that's in the divisor. So I'm going to figure that out on the side over here. So x times what quantity would give us negative 2x? Well, x times negative 2, right, will give us negative 2x. Right, so we're going to distribute negative 2. Right, so, okay, I forgot I can't erase these lines. So we're going to distribute negative 2. Right, so negative 2 times, oh, I'm sorry, before I do that, I should bring down negative 10. All right, remember, we always have to maintain two terms. All right, so now if we distribute negative 2 times x is negative 2x. So notice that first term should always match up. A negative 2 times 5 is negative 10. We have to change the sign. Right, and we have a remainder of 0. Okay, so we have x squared minus 3x minus 2 as the quotient. All right, so any questions about this example? All right, so this is a long division solution. Okay, so you will be using long division. You'll be using like a combination of long division, synthetic division, factoring, zero factor property. All right, so now let's take a look at synthetic division. Okay, this was actually from another textbook. I'm just kind of glancing through this. All right, so I'm going to just work out a solution. Okay, this is synthetic division. And I guess we'll answer this same exact problem. Okay, we'll just use another method. Okay, we know that our answer should be x squared minus 3x minus 2. All right, so I will, I guess, write the same thing. So we're going to divide x cubed plus 2x squared minus 17x minus 10 by x plus 5. All right, just to show that this method will give us the same result. Okay, so just as with long division, everything must be in descending order. Your divisor has to be in descending order, and your dividend has to be in descending order. All right. So now I'm going to take my divisor. I'm going to set it equal to 0, and I'm going to solve it. Right. So the first step is set the divisor equal to 0. and solve. So we have x plus 5. I'm going to set that equal to 0. So I have x equal to -5. This is your divisor for your synthetic division. All right. The second thing we're going to do is we're going to list out all of the coefficients of the divisor. Right. So what do I mean? Well, if we go back to our dividend, for my first term, the coefficient is a 1. For my second term, the coefficient is a 2. For my third term, the coefficient is -17, so you must include the sign as well as the value. And my constant is -10. Right, now here's the basic setup for synthetic division. All right, so notice a few things. So first off, the format is wildly different from long division, right? But there are some commonalities. Your divisor and your dividend must be in descending order, right? So we have our divisor, which is -5. We have our dividends, the coefficients of our dividends, right? We always add on the second row, and the first number always comes down, right? So now it's just a matter of multiplying and adding, right? So from this point, I'm going to multiply the 1 down here and -5. So 1 times -5 is -5, so I'm going to write that here as -5. So notice I'm multiplying -5 times 1, and I'm putting that result here, right? So now I'm going to add what's -2 what's 2 plus a -5? Well, 2 plus a -5 is -3. Right, so notice I am subtracting the 2 and I'm adding the 2 and -5. So now I'm going to multiply. I'm going to multiply 5 times -3, right, which is 15, and I'm going to put that result here. Right, a negative times a negative is a positive. 5 times 3 is 15. So now I'm going to add -17 plus 15, which is a -2. Right, and I'm going to repeat the process. -5 times -2 is a positive 10. And if I add -10 plus 10 is 0, and my remainder is 0. Right, but how do we get out this equation, right? That final answer, this x squared minus 3x minus 2. Right, well, in synthetic division, you're given the answers, but the answers are given out as coefficients. So one thing about synthetic division, when you use synthetic division, the degree of your original equation is lowered by 1 degree. So notice that we started out with a 3rd degree equation, right? The power was 3, the largest power is 3. Once we go through synthetic division, it lowers our power by 1. right? And these are our coefficients. So if we lower our power by 1, 1 would be the coefficient of the squared term. -3 would be the coefficient of the first degree term. And then -2 would be our constant. So this, in fact, would give us x squared minus 3x minus 2 as the quotient. All right. Right. So any questions about that first example? Right. You have to make sure everything is in descending order. Right. Make sure your dividend and divisor are okay. List out your, well, first off, take your divisor, set it equal to 0. Right. List out your coefficients for your divisor. And then it's just a matter of multiplying and adding. All right, now we're going to take a look at a second example. So give me 1 second to find a problem. Okay, here is one. I thought I had a good example. Tell you what, I'm just going to take one from the XYZ homework. That may be the best thing to do. Okay, let's say this. Okay, this one says use long division. Okay, that says use synthetic division. Okay, I'll tell you what, we'll do number 2, right? We'll use one that says use long division to find the quotient, right? 3x cubed plus 5x squared minus 4 divided by x squared plus 5. Okay, so we're gonna do this problem. And then we talked about synthetic division and long division. We're going to do a long division example first, and then we'll do a synthetic division example. Notice that this is a little bit different. Okay. So here again, I'm going to give you about a few minutes to work the problem. Okay, and then once you come back, we'll take a look at the solution. Okay, but I would really want for you to attempt the problem first, right, before we view the solution. All right, so I'll be back in a sec. All right, so let's take a look at the solution. All right, I want to give you a minute to attempt this one. First thing, notice that for the divisor, we do not have descending order. We have an x squared term and a constant. So we're missing the first degree term. So I'm going to set up the divisor as x squared plus 0x plus 5. Right, so notice I had to put in a filler 0x term. For the dividend, we have 3x cubed plus 5x squared minus 4. So notice we're missing the first degree term, right? So I'm going to put in 3x cubed plus 5x squared plus 0x, right? Because that's the term we're missing. We're putting in a filler 0 minus 4. So notice we have 4 terms in our divisor, right? So we're going to place whatever we're going to multiply by above the third term in our dividend, right? So just as before, we're going to concentrate on the first terms, x cubed and 3x cubed. Excuse me, x squared and 3x cubed. Right, so if I figure that on the side, x squared times what quantity, it is equal to 3x cubed. Well, x squared times 3x gives us 3x cubed. Right, so since I'm dealing with 3 terms, I'm going to put that 3x above the 0x. And now I'm going to distribute. Right, so 3x times x squared, that's our 3x cubed. 3x times 0x is 0x squared. 3x times 5 is 15x. Right, so just as in the previous example, you must change your signs. This is most important. All right, so once you distribute that negative, right, that's basically going to change everything to a negative. So that 3x becomes negative, 0x squared becomes negative, and 15x becomes negative. Right, so now we're going to subtract. So the 3x squared cancel. 5x squared minus 0x squared is 5x squared minus 15x. So keep in mind, since we have 3 terms in our divisor, we must maintain 3 terms. So we're going to bring down negative 4. So now we're going to figure out, right, we're going to concentrate on the first terms once again, x squared and 5x squared. Right, so x squared times what quantity gives us 5x squared? Well, x squared times 5 is 5x squared, so our magic number is 5. So remember, our goal is to make the first terms only exactly the same, right? And then once we change the signs, can we handle the other terms in the division? All right, so let's go ahead and distribute. All right, so here we're going to distribute 5. right? So 5 times x squared is 5x squared. 5 times 0x is 0x, and then 5 times 5 is 25. The next thing we must do is change the sign. Right, so I just want you to see where that comes in. Right, so the 5 first terms cancel, 5x squared cancels, negative 15x minus 0x is negative 15x. Negative 4 minus 25 is negative 29. All right, and this is our remainder. So now how do we write out our final answer? Well, just as in real numbers, we're going to put our remainder over the divisor. So we're going to distinguish this remainder with a plus. We're going to take our remainder, which is negative 15x minus 29, and we're going to divide by the divisor, which was x squared plus 5. All right, so this is our solution. All right. All right, so now we will take a look at an example using synthetic division. Oh, and for, okay, I'm gonna go back to, all right, so give me a minute, I'm just gonna switch screens here. I'm dealing with a couple of screens here. So we'll take a look at a synthetic division. Okay, we'll take a look at this one. All right, it says use synthetic division to find the quotient. And notice this one also has a remainder. All right, so I'm going to give you a second to work this problem, and then we will return with the solution. All right, let's take a look at the solution. All right. So we're gonna first off find the divisor, right? So if you take x plus 4, set that equal to 0, you should have -4 as your divisor. Notice that the dividend is in descending order, right? So the coefficient for that first term is 1, second term is 5, the next term is 4, 1, and 4. All right, so remember that first term always comes down. All right, so now we're going to simply multiply and add. So -4 times 1 is -4. 5 minus 4 is 1. -4 times 1 is -4. 4 minus 4 is 0. -4 times 0 is 0. 1 minus 0 is 1. -4 times 1 is -4. And our remainder is 0. Right, so remember that synthetic division lowers our degree by 1. Right, so we started off with a 4th degree. So these would be the coefficients for our polynomial. Right. So we can write out these. We can write out the quotient as x cubed plus x squared plus 1 plus 0 over x plus 4. All right. So kind of looking at these things, sometimes even though it may appear to have a remainder, the remainder could actually be 0. All right. Now, before we go any further, I want to show something with this calculator in general. All right, so give me a second. I want to pull out the calculator, and if you have your calculator, you may want to pull it out as well. Hey, before we actually get into any the analytical part of how to solve these equations, I'll kind of show you up front how to use the calculator, okay, to solve some of the equations. Now, once again, the calculator is not a substitute for learning. The calculator won't give you all the answers. For example, let's say you're trying to find the solutions for a quadratic equation. If the quadratic equation has imaginary roots, okay, you're not going to get any kind of answer from the calculator. All right, so the calculator only applies to functions that have real zeros. They really touch the x-axis. All right, so with that being said, I'm just going to take just a question. And here is one. All right, this thing says find all zeros, real and non-real. And this is where you have to be careful, real and non-real, right, of the function. So this is 4a to the 4th minus, it's 4x to the 4th minus 20x cubed plus 34x squared minus 36x plus 4. All right, so from what we talked about, the nth root theorem, right, this thing can have up to 4 solutions, right? I mean, it can hit the x-axis 4 times. All right, so I'm going to put this into the calculator. Right, I'm going to go into y equals. I'm going to clear out y sub 1, and I'm going to put in the function 4x to the 4th. So to put in a 4th degree, you're going to use this caret. Okay, that's our exponent key, so that raises that to the 4th power minus 20x raised to the 3rd power plus 34x plus 18. So I'm on a graph. I'm going to hit zoom and 6. All right. Okay, so notice that, and we'll have to get actually more into this to actually get the full scope of what's going on. But notice for this quartic, right, it only hits the x-axis twice. It hits here, and then it kind of bends up here, which will allude to the fact that we have 2 imaginary solutions. And then since this thing really does hit the x-axis here and here, we have 2 real solutions. Now the calculator won't actually give you the real solutions, but it will give you, I mean, it won't give you the imaginary solutions, but it will give you the real solutions. All right. In order to find the real solutions, we have to use the 0 function in the calculator. All right, so if I hit second and trace, which is calculate, here we can find this 0 function. All right, I'm going to put a video on the home page of Blackboard. I'm going to actually see if I can find it here. And at this time, I'm actually going to start the recording. So how can I do that?